Welcome to Ask and Learn.
Okay, so here we're solving the recurrence relation. an is equal to an minus 1 plus n times n plus 1 over 2. Okay, we can actually rewrite this as a n minus 1 plus 1 half n squared plus 1 half n. So that sort of separates out that second portion a little bit. So if we take the roots characteristic equation where we replace an with r, we would get r is equal to an an minus 1 will be replaced by 1. And then this last part, functions of n equal to 0, we just get r equals 1. So we don't have to solve anything. Our root is 1. And we know that the homogeneous portion, so put a little h up there, is going to be equal to alpha times 1 to the power of n, which of course is just alpha. So then we move on to the particular solution. And we will set that equal to our 1 half n squared plus 1 half n. And this is multiplied by 1 to the power of n. Okay, and so this is a root. It's our only root. And so that means that our particular solution is going to be equal to n times p2 times n squared plus p1 times n plus p naught times 1 to the power of n, which is just p squared times n cubed plus p1 times n squared plus p naught times n. Okay, and so now we need to solve some stuff. This must satisfy our recurrence relation. So that means that p squared times n cubed plus p1 times n squared plus p naught times n must be equal to, and so I'm just using our recurrence relation where an is equal to an minus 1 plus 1 half n squared plus 1 half n and putting this solution into that. Okay, so this is our an, and that must be equal to then p2 times n minus 1 cubed plus p1 times n minus 1 squared plus p naught times n minus 1. So that was our n minus 1 portion. Plus 1 half n squared plus 1 half n. Okay, and then we can expand these pieces here, and we will get p2 times n cubed minus 3n squared plus 3n minus 1 plus p1 times n squared minus 2n plus 1 plus p naught n minus 1 plus 1 half n squared plus 1 half n. Okay, then if we subtract some of this stuff from the left-hand side into the right-hand side, we end up with 0 is equal to negative 3 p2 plus 1 half n squared plus 3 times p2 minus 2p1 plus 1/2 n plus negative p2 plus p1 minus p0. Okay, and so now our coefficients have to be equal to 0 in order for this to be equal to 0. And so we just have a set of linear equations to solve. So we get 0 is equal to negative 3 times p2 plus 1/2. 0 is equal to 3 times p2 minus 2 times p1 plus 1/2. And 0 is equal to negative p2 plus p1 minus p0. Okay, so then we solve this, and so this one we can solve pretty well. We would minus 1/2 and then divide by negative 3. So that gives us that p2 is equal to 1/6. Then we can put that value into the second equation. So we end up with 1/2 minus 2p1 plus 1/2. So it's going to be 0 is equal to 1 minus 2p1. Okay, and so that means that p1 is equal to 1/2. And if we put 1/6 in for p2 plus the 1/2 in for p1, then we can solve for p0, and we get that p0 is equal to 1/3. So all of those are solved, and our particular solution is going to become, so it was p2 times n cubed plus p1 n squared plus p0 times n. So this becomes 1/6 times n cubed plus 1/2 n squared plus 1/3 n. And so now we just have to combine our particular and homogeneous solutions. Right, so we want our homogeneous and our particular solutions. And so our homogeneous one was just alpha, and we add that to the 1/6 times n cubed plus 1/2 times n squared plus 1/3 times n. And now we use our initial condition to solve for alpha. So we know that alpha 1 is equal to 1. So this means that 1 is equal to alpha plus 1/6 plus 1/2 plus 1/3. And we get that 1 is equal to alpha plus 1. So that means that alpha is actually equal to 0. So this means that an is really just equal to 1/6 times n cubed plus 1/2 times n squared plus 1/3 times n. Now, if we want to, we could make it so they have a common denominator of 6. And so that would give us n cubed plus 3n squared plus 2n over 6. And we could also factor out one of these n's. So we get n times n squared plus 3n plus 2 over 6. And you can simplify it further by factoring out this top portion here. So that would be n plus 1 and n plus 2. And I think all this factoring and simplifying might be extra, depending on your style, how you like to write it. So any of these forms would be correct.